So this is the NSA selector. It's a Eurorack module. It listens to Ethernet, to networks. It's doing just like the NSA does. It has 2 Ethernet ports and 1 audio output. And network-wise, it does nothing. It's just technically it's just a network switch, but with 2 ports, so everything that comes in on one side goes out on the other. The device itself is not speaking any protocol. It doesn't have the capabilities to allow you to connect to it. It's yeah, just like the NSA. But what it does is it listens into the network and converts it to audio. In this video, I'm going to show how to make a little sequencer using ping. Next, I will be adding an echo effect to the sequencer using tcpdump. Then tcpdump will be used to create a helicopter sound, and then it can be also used to saturate the link by amplifying the traffic. Then I'm showing some other sounds in the terminal that the terminal can do through SSH. After that I'm doing remote desktop setup, so we listen to things like xeyes or browser forwarding, but with a remote desktop, so everything visual will be audible. Then we accidentally and surprisingly create a drone synth with the site 2048.org, and we do this by disabling the ads. Then we show what Google Maps sounds like, and then we listen to a few bitmap images. Bitmaps are uncompressed and unencrypted, so you can really listen to the pixels while you watch them in your browser. Then we do something quite the contrary, so we kind of swap the roles. So we intentionally create a sound that's in the format of the NSA selector. We are using a sigma delta converter to upconvert conventional WAV files, audio samples, to 4-bit and 25 megasamples per second, which is the NSA selector's native format. I hope you enjoy the video, and if you do so, please don't tell anyone about this, as this is classified stuff and it's top secret. Okay, here we go. This is the NSA selector video. Here you see the NSA selector in my little rack, and there's 2 network cables. I'll unplug them. So we have the audio. There's just 1 audio jack. The bottom hole is for LEDs only, and you connect 2 Ethernet connections. So this one, the black one, goes to my local network and the internet, and this just goes to 1 dedicated machine. You can try different setups and play around, but for now I want to show something with 1 machine that is isolated behind this cable. And now you can already hear some broadcast packets from my network, from other machines, from the router. Very silent, very little traffic is going on now. And now I plug my laptop machine. They start some negotiation forth and back. Initially, when the link comes up, they talk to each other and figure things out, and then it's getting kind of silent again. Okay, now let's play with the terminal. So here we have the terminal. One first obvious thing you can do on a network is ping another machine. So let's just ping the other box. And you hear a very silent click every second. You can set up your 24 track and record it, and you have a click on the 24 track. Quite annoying. So you can set this to just one packet, so count 1 is the parameter C1. Now you probably hear more of my keyboard than the click, but we can change the size. Now you clearly hear the packet, it's just a larger packet than before. Now with 999. We have very distinctive clicks, beats, you can say. So what if we do just like a small crappy sequencer? We edit beats.txt and we insert numbers 120, 9001, 80, I don't know, 50, 2000, 3000 even. Yeah. So we have this text file. We can cat it, which just displays the contents, and we can do something on the bash, on the shell. If we have a nice terminal, we can do like for delay in $cat beats.text :do ping minus count 1 packet to 192, 168, 125 minus size $d from this file, from this text file before, and we're done. Oh, now that went too quick. All the packets quickly were sent one after each other. So let's add a sleep. Sleep 0.2, 200 milliseconds between each beat. And we get a kind of a rhythm, just we have to start it manually. So let's do another for loop or while true. :do, done. Now we have created a sequencer. That's a valid sequencer. We can even live edit the beats.txt. No, I'm in another directory. Prompt is set up weirdly. So let's reduce this 444 click. Let's reduce it further. Okay, you see, you can live edit and play around. The script is not in this state, it's not really robust, or if the link gets saturated, it starts timing out and you lose the rhythm. And let's go ahead and git clone a repository called the NSA selector, and guess what? It's related. The NSA selector, here's a sequencer, and here's a do beat script, and you give it a parameter beat 0, or you choose another one. If you want to change the IP address or things you edit in this text file, here's the tick, so that's 200 milliseconds. We can change this to 123 milliseconds if we want. So that's quite a speed up. Okay, so we have a sequencer, which is already nice. Let's just keep this running for a moment. Not that fast, maybe. And now I can simultaneously log into the remote machine. So here, this terminal is now on the remote machine, and there's one fun thing to do. I can add an echo. So I can watch the traffic of the network just by doing a tcpdump here. This got kind of weird, you know. We did too much traffic because we're also listening to the SSH traffic now, and this kind of gets in a kind of an avalanche. Not yet, but we'll get to that later. So let's add an echo. So what we do here on this other terminal, that's ping. Ping is ICMP packets. That's a protocol type, and we filter. We just now want to look into ICMP packets. So we added an echo. It's not exactly a delay because we can't control the timing very much, but to each beat we added another second beat, which is the SSH protocol reporting back to us this terminal printout. Now we can make this louder, increase the echo by increasing the verbosity. We can even dump the whole packet in hex, which is even louder. So now the echo is louder than the original, but it's a nice effect we can use. There's more nice stuff we can do. We stop the sequencer for now, and we just listen to, so we want to see what packets are, what's going on anyway on this machine. So this is now a lot of SSH traffic itself, so the traffic we see, we also hear, but it seems to be logging less than it's actually using on the wire. That's because it's not printing the whole packet, just some header information. Now if we increase the verbosity here without the filter for ICMP, this starts to get in a nice territory, in an interesting area. This is kind of avalanching, starting to avalanche itself. Sounds like a helicopter here. So this is not yet really an avalanche. It's not yet fully saturated the link. We can tell this also by 0 packets were dropped by the kernel, because if we really saturate the link and it doesn't manage to get to report back all the packets, it will drop packets. So when we hex dump the packet, this is getting too much, obviously, because we report more bytes back than are transmitted on the wire. So this is now getting into an avalanche quickly. Let's hear it. And in between it stops from time to time because it has to do retransmissions. There's missing acknowledgers on the TCP layer going on, and SSH is missing the data and retransmissions happen on the TCP layer. And as I said, the link is saturated now. Okay, either we get this error message, unable to write output, or sometimes we get lost packets. Not this time. Here we see we have how many packets were captured, and the kernel knows that it dropped some packets which he didn't report to us on the console because he didn't he couldn't keep up logging all the packets. So this is from very simple ping to advanced echo effects, and then avalanche effects on the network. You can trigger if you have a remote machine like a Raspberry Pi or a desktop system running Linux, MacOS, Windows. You can all set up these machines to allow for SSH connections, or you can also use on a Windows box, you can use other protocols or remote desktop to have similar effects. Okay, there's other obvious things you can do. I'm remotely connected here, so everything I type will be audible on the network. And if I do something that updates the text screen, the terminal, like htop, you can hear a click every 3 seconds because it's updating every 3 seconds. But with F2 we can set it up so it's doing things faster. And the interface is kind of weird because I have to press minus and only can do this in steps of 100 milliseconds. Let's do it to 100, set it to 100 milliseconds, and I'm done. And I have to restart htop for some reason. Now you hear every 100 milliseconds you hear the screen update through SSH. There's also the ancient top version, which is in this regard nicer because you can set the delay to arbitrary numbers by pressing S. You can set it to like 50 milliseconds. You can set it to like 10 milliseconds. But here you hear this should be 100 Hertz now. But you hear it doesn't keep up, so sometimes it's slower and faster. It's a race. And you can set it up to 1 millisecond, 1 kilohertz, it won't keep up. And obviously we want to set it to 0 to hear how fast the machine is. What directory could I find? Okay, now you see more of my screen. If we log in, I have to log out first from the remote, and if we log in again with X forwarding, so that's a kind of remote desktop interface. Yeah, I think our desktop for Windows and TeamViewer style or screen sharing, or yeah, this stuff. And you can do fun things like start the next term. Here it is. Don't know why it's taking so long. But you can hear events like the mouse over event is reported through the protocol. Oh, and beautiful. Unicode fuck up. Oh, I shouldn't say fuck. So fronting is always xeyes. Okay, I can keep them running, but every mouse movement will make this annoying thing. Let's start, I don't know, browser, why not? Chromium. But it's still starting up. Actually, I don't know what it's trying to load. Let's just try to go to some URL. Kill the xeyes. Continue. This is really slow. Desktop forwarding on X protocol is nothing for 2025. It's really laggy when I scroll down. But it can be fun on sites that are like vivid or do something or show something, but they don't create network traffic themselves. So if you have a site like playing the game 2048, it won't create network traffic, but it might be fun to listen to here. I haven't tried it. Let's see. Now we... This is what web browsing sounds like. Oh, and we get a second click. Here from the clock, obviously. I click the image, it should change. There we go. And another click on the dark image. Now they are faster. Not this one. Okay, let's try 2048.org. Doesn't want to open a new tab. You really should try. Every website sounds different. I have this just set up since yesterday, but the things I've heard is really fun. 2048.org. Let's close this clicking tab. Waiting for silence. Still, okay, the ads are loading. Okay, that's not too exciting. Probably it's more exciting to scroll to the ads or whatever is there. Wow! These are the surprises I love so much. Who needs a drone synth? Okay, so this was kind of remote desktop. Awkward experience, and obviously a browser is a heavy load for a remote desktop. Things, I don't know, I don't have any idea for a lightweight thing we could try now. That like xeyes, probably games would be an idea. I'm not prepared for this. Okay, what else can we do? We can now, we could just switch locally. Okay, this is now, as you can recognize, the same website as before. It's just locally now. So the thing is, why don't we hear anything now? It's because I have to switch. So let's do this. So the connection is switched. There will be a lot more artifacts due to the lots of software that is running currently on my box here. But we can listen on websites, and this is also a lot of fun. Now the difference is I'm not forwarding the display, so this is lag free, so it's 100 megabit per second. But if I load a page like this, this will create network traffic, and not the, okay, the images are all preloaded, so just if I do a reload, it will create the same noise probably again. I haven't tried this before, it's fun. Let's try some doom scroller. Like this is it's just an account on a social network, Mastodon. It's generating images, so I think the content is innocent, and it's not reporting about wars in Europe or elsewhere. Okay, so it loads content in a block. Okay. Okay, let's do something new, something different. Let's transfer images, but here we have JPEGs, so they are compressed. They sound like noise on the network. I can reload the image, but it's the file size is too small. But if it's a real bitmap, we can listen to the image. And here we have a few nice images. Let's play around with them and see. We probably have to increase the size so the transfer takes a few seconds and we have a real audible noise and not just a click like this one. Let's save the image and maybe a few more. Now let's make bitmaps out of them and increase the size. Edit these images, maybe make them larger, like I prefer percent. 4 times, I don't know, it's 4000 by 4000 pixels then. Should be fine. No, 400% scale. Yeah, that's fine. So this is 100% file export as, and now we write them as bitmap files. We have an option. I think 24-bit is fine. Right color space. Don't add overhead. Export. Then the next one, image scale. So now we have these bitmaps here, and we need to copy them over to the remote machine. But first, maybe on the remote machine we also clone the Git repository and go into the directory, the NSA selector file server, and yeah, we can use this directory, and now we copy bitmap files to this directory and files on the server machine. Lazy. I don't want to type, so now this transfer obviously is encrypted. Nothing to hear here other than white noise, basically. So, but now we have on the remote machine, we have this file server. Well, we can just run it, and it's listening on port 8000. So let's try to go there. Yeah, it's already in history for whatever reason. Isn't it great? You hear the image. This one's good. So that's just a basic Python web server, and it's listing the files. And it's not HTTPS, so it's not secure, not encrypted, so we can listen to the pixels. Let's just create another image. just a square image, fill it with a color, then draw around with a brush and some size. So copy over. Where's the file server? Here. Reload. Here we have. So it's really worth playing with patterns, with sizes, and file no. Great one. So that was file transfer. Then there's this other thing. Okay, that's a remote speaker, but maybe you heard it. It's just a wall clock ticking. It's a phone ring. Let's take these two. So let's convert these using SOX. We need 48 kilosamples, so you just convert the input file, minus R 48,000 is our new rate, and we say it's still called phone.wav, and then we do the same with the wall clock. and convert phone.wav to a phone.nsa. We need to start the file server and reload. And now we have these huge NSA files compared to the original WAV. We can load the WAV file, but it won't be very audible. So that was it. Now this is the way it sounds on the network. When we upconvert it, the sampling rate to be 4 bits and 25 mega samples per second. It's the long word clock sample. So this was another way to intentionally convert a WAV file to match the format of the internal network adapter of 4 bits wide and 25 megasamples per second. So this is it's called a sigma delta converter, and it resamples it for 4 bits. So effectively this way it doesn't remain 4 bits. This way it's going above more than 9 bits you get. Okay. I hope you had fun by looking at these different wild styles of listening into your network. I hope you'll enjoy your own NSA selector soon. I'd appreciate. That's all for today. Thanks and bye-bye.